Hello. I hope that everybody's well, keeping healthy, and doing all that stuff. Okay, so we I put videos up for 7.1, and that's what's on quiz 5. And I put up 7.4, integration improper integrals. And so 7.4 and 7.5, that will be on your quiz 6. And then there's test 3. But these are standalone sections. You can do any one in any order. It's not building on anything. So let me just get started. So here, let me get the thing to work. All right, so here I have definition. And I don't normally ask you a definition, but we have to talk about this. It's 7.5 is probability. And we're going to be dealing with probability density functions, okay? All right, so let's just look at this part right now. It says, if X is a continuous random variable distributed on the interval AB, then F is a probability density function for X if two conditions hold. One, it has to be greater than or equal to 0 for all X in the AB. And the integral from A to B of f of x equal to 1, you go, okay, well, what does that mean? Okay, so what that means is that this is what it looks like. If we have a function, continuous function, on the interval from A to B, okay? All right, so it's a probability density function if the function is greater than or equal to 0 for all X in AB. Well, what does that mean? It means just it lies above the X-axis. So it does lie above the X-axis. So f of X is, this is where X is equal to 0, right? For all X, lies above the X-axis. And that's condition 1. Condition 2 says, if I integrate A to B, if I integrate my function from A to B, I'm going to get 1. Okay, and what does that mean? That means there is a 100% probability that if X is a continuous random variable, there's a 100% probability X lies in this interval. Okay, all right, and so here's my definition again. And so before we, edited what you would learn from each section, we would give you a function on an interval and say, is it a PDF? And you would just check, is it positive? Yep. Is the integral from A to B equal to 1? Yes. And if those both conditions hold, then it was a probability density function. And then we could use the probability density function to find probability. But let me show you what I'm talking about. You really won't have to do this, but it's good to know what I'm talking about. So if I said, if I gave you a function, f of x is 1 over 12 times x on the interval from 1 to 5, and I ask you, is f a PDF on the interval? Okay, so two conditions would hold. We would have to go, well, is my function positive on the interval? And so my function is 1 over 12 times x, and my interval is 1 to 5. Now, if we had a graphing calculator, we could graph 1 over 12 times x and look at the picture of it from 1 to 5, and it would be positive. But if we were doing this without a graphing calculator, if you from 1 to 5 looks like this, I mean, it's infinite, right? But you know that if you plug in any number, including 1 and 5, if you plug it in for x and multiply it by 1 over 12, it's always going to be positive. So that condition holds. But we would have to check, is the integral from 1 to 5 of 1 over 12 times x, Is that equal to 1? So we could check that. So the integral from 1 to 5 of 1 over 12x dx is 1 over 12 and then x squared over 2. So my antiderivative is x squared over 24. And if we evaluate it from 1 to 5, maybe you should be able to see. If we evaluate it from 1 to 5, f of 5 minus f of 1. So if I plug in 5 for x squared, I get 25 over 24 minus, if I plug in 1, I get 1 over 24. So when I evaluate it, I get 24 over 24, which is what? 1. So we would say yes. Is f of x equal 1 over 12x a PDF on that interval? We would say yeah, because we check both conditions. And if you get 1, it is, and if you don't get 1, it's not, just so you see it. So if I ask you, is f of x 3x squared over 128, is that a PDF, probability density function, on the interval from 0 to 4? So we'd have to check. Well, is f of x greater than or equal to 0 on the interval? Well, I don't have a graphing calculator, but if I plug in 0 and 4 and anything in between, and I square it, and I multiply it by 3 and divide it by 128, it's going to be positive. And that's how we would have done it in class and for homework. So now we'd have to check condition 2. What's the integral from 0 to 4 of 3x squared over 128 dx? If it's equal to 1, then yes, it is, but we don't know. So let's go check that. It's equal to 3 over 128, right? X cubed over 3. So my antiderivative, you can call it 3x squared over, but I'm going to call it x cubed over 128. It doesn't matter if you reduce it or not from 0 to 4. So f of 4 minus f of 0. So 4 cubed is 64 over 128 minus 0 over 128. So that's 64 over 128, which is actually 1/2, but you don't have to reduce it. So is f of x a PDF on that interval? No. Okay, because the integral is not equal to 1. Okay, all right, so there you go. If you had to prove, is something a PDF, then that's what you would do. You would integrate it and you'd make sure it's positive. Okay, but let's look at the second part of the definition that we are going to use. Okay, and I just like to show you with examples because all the words and letters get to be too much. Okay, all right, so let's say we have a probability density function. It says if CD is a subinterval of AB, then the probability that X lies in within C and D is just that indefinite integral. So look, let's look at an example that we've already worked. Okay, what did we say yes to? We said yes to the dress, all right? Okay, so let's go back to this example. We said f of x is equal to 1 over 12x is a PDF on the interval from 1 to 5. Okay, it is. All right, we already know it is. So what if we wanted to find the probability that X is in between 2 and 4. Okay, all right, so all this stuff about subintervals, and this is what I'm talking about. Okay, so if CD is a subinterval of AB, then the probability that X is in the interval CD is, we just set up the definite interval, okay? This is all on page 3 of 10 in your Learn of 7.5. But let me just show you what that means. So we know that f of X is a probability density function between 1 and 5. There's 100% probability X is in that interval. So now we want to find the probability that X is in between 2 and 4. So the probability that X is in between 2 and 4, which is just a subinterval of that. Okay, we're looking for that probability. So we're just going to integrate from 2 to 4. So again, we just set up the definite integral. Does that make sense? So that's what we're going to do. They're going to give us a PDF on an interval. So we're supposed to know that if I integrate from 1 to 5, there's a 100% chance X lies within that interval. But now they say, well, what's the probability X is in between 2 and 4? Well, what's that probability? All I have to do is integrate it from 2 to 4 to find out. Okay, so that's not too bad. So it's X squared over 2, right? So my antiderivative is X squared over 24. And if I integrate it from 2 to 4, I get F of 4 minus F of 2. And plug in my 4, and then I plug in my 2. 16 over 24 minus 4 over 24. So that gives me 12 over 24, okay, which is 1/2, and it doesn't matter. So there's a 50% chance X lies within this interval. Okay, so when you're finding the probability, it's always going to be positive, and it's always going to be less than 1, because there's a 1 means there's a 100% chance that X lies within that interval. So if you get a negative number or a number greater than 1, you'll know you did something wrong. Okay. All right, so let's look at the homework. You ready? Ready. Okay. And let's see. Find it. My sweet husband printed it for me, okay, the homework, and brought it home to me. Okay. All right, so let's look at this. And I believe there are only 5 problems in this. And did y'all just hear that rooster? I don't even live in the country, I swear. Okay, it says the probability density function for an experiment is given by, and that's hard to see, so I'm going to write it out. F of X is equal to 1 over 4x. And then they put a comma after it, which sometimes looks like an exponent, but it's just F of X is 1 over 4x on the interval from 1 to e to the 4th. And I don't know why they just all of a sudden start doing that when this is 1 comma e to the 4th. It's the same thing. This is just more familiar way that we've been writing it. Okay. All right. So we know, because f of x is the PDF on this interval from 1 to e to the 4th. What the heck is e to the 4th? I mean, it's just a number, right? So if we said second function ln e to the 4th, it's like 54.6. Okay, so there's a 100% probability x lies within that interval. Okay, we don't have to check that. I'm already telling you that. Now it says, well, find the probability that x is in between 1 and 16. So the probability that x is in between 1 and 16 is, here, let's say, we're looking for this probability. Let's call that 16. Then we're just going to set up the definite integral. The integral from 1 to 16 of 1 over 4x dx. So we're just setting up the definite integral just like we did for area. So remember, I do not bring up the 4. That's the biggest mistake, is the rewrite. Okay, so that's the integral from 1 to 16 of 1 over 4 x to the negative 1. Okay, and we're just using my 6.1 rules here. Now it's late in the afternoon, 1:28, not late in the afternoon, and there's a crazy rooster outside. Okay, so what happens when I add 1, I get 0. So what does that mean? That my antiderivative is what? 1 over 4 times the ln of the absolute value of x. And I'm going to evaluate it from 1 to 16. Okay. So we know how to do that. We do it on our calculator. So that's f of 16 minus f of 1. And you can do it exact, or you can do it in your calculator, but I'm going to put 16 in my calculator. It's a great time for any of those of you that don't know how to do that. I'm going to do 16, store for x, and enter. I'm going to type in my antiderivative. 1 divided by 4 is the ln of x. Enter. So I get 0.3466. Okay. And then if I do 1 and store for x and enter and go put it in my antiderivative, that's not true because I was supposed to put x. So yes, so that one's true. So it's 0. So the ln of 1 is 0. So let's just make sure I put the 16 in, and no, that's 0.6931 minus 0. So pretend like I didn't make any mistakes. So 16, store for x and enter, and we put 1/4 ln of x, and that gives me that, minus 0. And it should tell me how to round. So let's look and see how to round. And be careful because rounding will matter. And it says leave it exact or rounded to 3 decimal places. So leaving it exact or rounding it to 3 decimal places will give me .693, and the exact would be 1/4 ln of 16 minus 1/4 ln of 1. And ln of 1 is 0. You could do it like that. You could put it in as a decimal, but remember that's 1/4 ln of 16 over 1. So that's how Hawks would put it in. But this is what I like to do. Okay, so all we're doing is setting up the definite integral. They're giving a PDF to us on an interval. Okay, so we're finding some probability. Okay, so here we go. Let's look at problem number 2. Okay, it says the outcomes of an experiment are distributed exponentially according to the function f of x is 0.1 e to the negative 0.1x, where x is greater than or equal to 0. Okay, what is the probability that x is in between 60 and 90? Okay, all right, so how are we going to do that? All right, so first off, it's telling me that f of x is equal 0.1 e to the negative 0.1 x is a PDF for all x greater than or equal to 0, which just means from 0 to infinity. Okay, it's an improper integral. And if they want to know the probability that x is in between 60 and 90, they're just wanting some subset right here. And that's what we're looking for, the probability, because there's a 100% probability x is greater than or equal to 0. So we integrate our function from 60 to 90, 0.1 e to the negative 0.1 x dx. Okay, and it's my 6.1 rule, which makes my antiderivative 0.1 e to the negative 0.1 x divided by negative 0.1. Okay, I think it's easier to call that negative e to the negative 0.1 x from 60 to 90. So f of 90 minus f of 60. I'm going to do that on my calculator. I'll do unclear. I'm going to put this thing in. It's already in. So 90, store for x and enter. I'm going to type in my antiderivative, negative second function ln e to the negative 0.1 x. And I get negative 0.000123. I'm going to just write it all down because there are a lot of zeros. And 60, store for x and enter. And go up and highlight my antiderivative. And I get negative 0.002479 for the sake of running out of room. But remember, I don't type in those numbers again. I go up and I highlight my 0.0001, enter, minus, and I go highlight that, and I push enter, enter, and I get 0.002355. And let's look and see what they told us to round it to. Okay, 4 decimal places. Okay, so if I round it to 4 decimal places, 1, 2, 3, 4. So I'll look at this number, and so that's going to be 0.0024. And that's what I type in. And you can do the exact, you can leave it in terms of e, which would be negative e to the negative 9 minus a negative e to the negative 6, which would be negative e to the negative 9 plus e to the negative 6. But I just like that better. All right, so either way, but that's how Hawks will give you your answer. Exact, and that's the approximation. Okay, so all we're doing is setting up our definite integral. Okay, all right, let's look at the next question. Okay, and they do a lot of these same exponentials where the number in front, like e to the negative 0.1x, and I have 0.1 in front. This is 0.3, and I have a negative 0.3x. So a lot of those are probability density functions. So it says, on the freeway during rush hour, the distance x in feet between your car and the car behind you has this probability density function. So let's write that down. On the for all x greater than or equal to 0, and I'm running out of paper. Okay. So my probability density function, there it is. Sorry. I'm making you sick, moving around so much. So it says, on the freeway during rush hour. Here's the probability density function. So f of x is 0.03 e to the negative 0.03x is a PDF from x is greater than or equal to 0. So from 0 to infinity, if I integrate it from 0 to infinity, there's 100% probability x lies within that interval. But they want to know, what is the probability that the car behind you is within 19 feet of you? So they want to know this. It's either 19 feet or inches, right? It's right in your bumper. So what are we going to do? We're going to, within 19 feet of you, we're going to set up the definite integral. That's going to be from 0 to 19 of 0.03 e to the negative 0.03x dx. And so my antiderivative is just my e to the kx, 0.03 e to the negative 0.03x divided by negative 0.03. So that's just too easy to call negative e to the negative 0.03x. And we evaluate it from 0 to 19. Okay, be very careful here, because a lot of times when we plug in 0, 0 makes everything go away, but not when it comes to e's. So f of 19 minus f of 0. So let's put that in my calculator. Clear it out. So it's 19, store for x and enter. And my function is negative, second function ln e to the negative 0.03x. Enter. And I get negative 0.56553, okay? And then when I do 0, store for x and enter, and I go up to my antiderivative, I get negative 1. So when I go up and I highlight my negative 0.5655 number minus, and I go up and grab that negative 1 and push enter twice, then I get 0.43447. And let's see what they said about rounding. This one said round to 2 decimals. Okay, so we can do that. So that is going to be, my answer will be 0.43. And then if you want to do the 19, the exact, you would just say negative e to the negative 0.03 times 19 to the negative 0.57, and it'll be plus 1 is the exact. Okay, all right, but that's what I do. That's what Hogs does. Okay, all right, and there's just one more type of problem, and we're done. We're done with everything for the whole test. And these are just setting up definite integrals, so it's not that bad. And actually, I'm doing 2 of the next problem because it's a little different, but we're okay. Okay. All right. So you see 4 and 5 are kind of the same, but I want to make sure we get it right. So an experiment has a probability density function, f of x is 1 over 18 times 6x minus x squared, where 0 is less than. All right, so what it's saying is that f of x is 1 over 18 times 6x minus x squared is a PDF on the interval from 0 to 3. So remember, what does that mean? If I were to integrate from 0 to 3, I would get 100% probability x lies within that interval, okay? So now they say, once you have the PDF, find the probability that x is in between 1 and 2. So we're looking for this, for 1 and 2. We're looking for this probability, okay? So what do? We just integrate from 1 to 2 of 1 over 18, 6x minus x squared dx. Okay, so let's talk about this integral. And it's the 1 over 18 that's kind of different, right? Now, I used to distribute it through, and it was a nightmare. So now I rewrite this. I take the 1 over 18 out, but don't forget about it. I'm going to integrate from 1 to 2, 6x minus x squared dx. I think it keeps us from dealing with fractions so much, but just don't forget to bring it along, because sometimes if I bring things out, I forget about them. And so 6x squared over 2 minus x cubed over 3 from 1 to 2. So I'm going to find f of 2 minus f of 1. And y'all, I'm plugging this in my calculator just like this, okay? I'm going to say 2, store for x, and enter. Can y'all see this? And then I'm going to do my 1 divided by 18, parenthesis, 6x squared over 2 minus x to the third divided by 3. And enter. And I could 14 over 27. I think they'll let you leave a decimal. Minus, if I do 1, store for x, and enter, and plug it in, and go back up there. I get 4 over 27. Well, and I know that's 10 over 27, but let's just say I didn't know that. 4 over 27 minus 14 over 27, that's 10 over 27. And really that doesn't tell me very much. I don't know if they let you round it. We'll go look at the directions, but to me, that's about a 37% chance that x lies in that interval between 1 and 2, which kind of makes sense. All right, so let's go read the directions and see what they said. If I could find them. Okay, here they are. Well, you would think. I'm just sitting right here. I haven't gone anywhere. There it is. Okay. All right. Well, it doesn't say anything about rounding, so I'm betting you that they won't take a decimal. So let's leave everything as a fraction. So we'll leave it as 10 over 27. Okay. They don't say anything about rounding. When they don't say anything about rounding, what does that mean? That means they won't take a decimal. Okay. And the last one is just like it. I just wanted you to see about this number on the outside. So I have a PDF from 0 to 3, and if we find the probability x is in between 1 and 3, we're just going to integrate from 1 to 3. We'll put that 2 over 45 outside and do 7x minus x squared dx. And we just can't forget about that 2 over 45. So that's 2 over 45 times 7x squared over 2 minus x cubed over 3 from 1 to 3, because it's a PDF from 0 to 3. That's a 100% probability. So we're trying to find now what this is from 1 to 3. Okay? All right, so f of 3 minus f of 1. So let's keep everything as a fraction, but don't forget when you type in your function to put the 2 over 45 in there. So we'll do 3, store for x, and enter. And 2 divided by 45, parenthesis. I like to do 7 divided by 2, x squared, minus 1 divided by 3, x to the third. However you do it your way. And it's 1 minus, and then 1, store for x, and enter. And we put that in, and we get 19 over 135. So let's go and subtract 1 minus 19 over 135, and I get 116 over 135. And that's my answer, but I like to check to see what it means. And that they're saying it's like an 86% chance that X lies within that interval. And that makes sense to me, because if it's 100 between 0 and 3, between 1 and 3, 86 makes sense. And that's it. That's all you have to do for section 7.5. And so I hope the videos help. You know, they either do or they don't. They'll help some, they won't help some. You have your Learn, there's Hawks TV, there's Hawks videos, there's PowerPoints, you know, and so that's all the material for test 3. Test 3 will be taken just like a quiz. It will not be proctored, okay? And you could take it anytime. There's no start. You can start right this second. And so, but there is a hard end, I think it's April 12th, that you'll look at Hawks and see. And I also uploaded a new syllabus. I uploaded a new calendar. Check those things out. Read the stuff. Watch the videos. People are emailing me about things that I'm saying, watch video. And one thing I do want to say, I realize that you want to see your scratch work from test 2, but I'm still quarantined for 10 more days, so I can't go anywhere. But I will get that paper. We will figure it out. You will get your points back, but it's not going to be right this second. But we got a little while, so just be patient. Don't panic about it, okay? I understand. I got you. I got you covered. All right. Well, happy Friday. It's like every other day. Have a good weekend. I'm gonna work test 3 out, the new test 3. There's the old test 3. I'm gonna work the new test 3 out, practice test 3, and post it on Blackboard, and you'll be all set. So I'm hoping that you won't all wait till the 12th, that you'll go ahead and get this done, because I'm worried about your other classes more, that you know, maybe they'll be harder online. Okay, so give yourself plenty of time. All right, have a great weekend, and I will see you soon.